Hello guys, still Monday. Let's continue with the repair things. So we have this package is also coming from another city. I just finished fixing a Lenovo laptop which was coming from another town, which is Matopo. This is coming from another town, the second largest city, which is Bulawayo, to BST African Electronics Surgery, Rwanda town. HP 250 G5 motherboard, no power, blown up. From Bulawayo Laptech ICT Bulawayo Center. Okay, and the contacts. So yeah, the owner phoned me. He said he opened the laptop. Is the guy who is in Bulawayo, second capital city of Zimbabwe, and he's also fixing laptops there, specializing in laptops. You know, people, they don't want to learn electronics. I don't know why. People, they are specializing. Me, I only fix TVs. It doesn't work that way. Learning electronics, you should be able to fix anything. So let's see what is inside this package. Oh, like a fried motherboard. Okay. Check here. What is here? Maybe you can't see. We have the charging port here, and on the other side, maybe you can't see due to some reflections, but this whole area is blown up. The input MOSFETs, all of them, they are blown up. We do have some inductors connected in parallel before the MOSFETs, also blown up, and some components here, they are blown up. This can be a disappointment. Hopefully, our ENE chip here, the SIO chip, is good, and the processor. Otherwise, we can't do anything. So, what I was saying, we don't want this envelope. We don't want this envelope, and we need a closer view of this. Need a close-up, something like that. So what I was saying, I was trying to say, people, they don't want to learn electronics, and I don't know why. People, they are only interested in fixing certain line of devices. It doesn't work that way. So even this laptop, this motherboard for HP 250 G5, which is coming from Bulawayo, this is from another computer shop, but they are specializing, which I don't understand why. So I don't want to start working on this area before I'm satisfied that this board still has got some life. So what we want to do, let's check the resistance of each and every coil to ground. This one not shorted, this one not shorted, and this coil, you see, they are together, meaning to say that is the 3.3 and 5 volts power supply. 2 coils, the driver, like I believe these are the MOSFETs, like Joa MOSFETs, and here you see those small guys on top. Those are ceramic capacitors. They are connected on the 19 volts power rail. So here seems to be good. On the other side we have the output electrolyte capacitors. This one we have another coil which is next to the RAM. I believe this is the RAM power supply and it's not shorted to ground. Here we have 3 more coils. We have this one, it's not shorted to ground. We have this coil, then this coil is not shorted to ground. What about this one? Maybe my multimeter is faulty. So this one, that's not normal. Usually there must be 1 or 2 coils, 2 coils or 3 coils beeping to ground, because the resistance of the GPU and processor power supply is very low to ground. So there must be some coil beeping. That's not a problem. So what is the next step? We've checked coils. Let's check capacitors around the ENE chip. Maybe we have a blown up ENE chip here. According to multimeter, it seems fine. So let's jump and check some things. Charger, 19 volts on the charger, 19.67. Plug in the charger. Obvious, we don't have light here. That's an obvious case. On HPs, it's very simple. If the 19 volts is present and 3.3 is present, we must have light here on the charging port. So checking for 19.67, and before the MOSFETs, after the MOSFET 4. After the first MOSFET we have a 4.23 volts. On the input we have 19. Why? Because all the MOSFETs, they are blown up. So it's very simple. I'll use, like usual, we use our alcohol, isopropyl alcohol. Let's clean this board. Let's clean up this board. Well, that's the only way we can see what's going on there. We need to see. So the next step, first MOSFET and second MOSFET all blown up. So let's check out those MOSFETs quickly. With the 450, I can't check out the MOSFET. Yeah, the MOSFET is out. The second one. The second one is out. When those carbon resistors or small inductors, whatever I call it. So let's check for shorts on the current resistor after the two MOSFETs. We don't have a short. Now let's replace those MOSFETs quickly. Let's replace those MOSFETs quickly from another board for space. The first one is in place. The second one, all the MOSFETs has been replaced. Let's replace those small coils, small inductors, whatever I call it. I don't mind. Okay, we need one more. Yeah, all the blown up components, we have replaced them, but we have to check here. We have a capacitor and both sides they are reading short. I don't think this capacitor is good. Let's take down that capacitor, ceramic one. Let's try to rebuild this area. Another capacitor. I do have a board similar to this for space. Our capacitor in place. Okay. So we have replaced like all the input MOSFETs, the carbon thing. Let me check something just to clear everything under microscope. So yeah, the board is too warm, but we can dry it quickly so that we test. It's that moment to see either we are winning or not. That's the moment. Still no light. Okay. That's interesting. That's so interesting. So what's going on here? On the output 0. The question is why we don't have voltage on the output. 19 0. Next here we do have the BQ chip. we must have V in. .65. $19. Yeah, something is not right here. Something is not right. So yeah, let's unplug here. So why those MOSFETs, they are not outputting 19 volt, the first MOSFET? Problem, I just took out the MOSFET from another faulty board. Maybe one of the MOSFET is not right. So let's take down those MOSFETs and we do the right procedure. Our MOSFETs are out. Let's check for our MOSFETs. The first one, is good. The second one, all the MOSFETs looks good. All the MOSFETs looks good. You know, the problem with this board is coming from another technician, so we can't do shortcuts like jumping over the first MOSFET with the wire. We have to be professional. We can't do that. We are doing that some days, but to someone who has put trust from another town, we can't. Let's put the second one. Let's try to check further. Let's try to check further. Yeah, the board is too hot, but we can check. Zero, zero, I don't know if you can see. We have the first MOSFET, the second one, and after the second one, we have like a capacitor here, and this capacitor is shorted. I don't know. Let's look at the voltage. I don't know whether the fault, the capacitor is shorted or something else is shorted. So I'll lower the voltage. Two volts, 2.5 amps. It's taking 1.2. This side is taking 2.5 amps. The other side of the ceramic capacitor is taking 1.2. And the BQ is getting hot. What did I told you? I want you to see. So let's raise the voltage a little bit. Anyway, there's no need to check. The BQ chip is blown up. We know the charging controller. Same boards like twins. So let's replace the BQ chip. Let me see what kind of BQ chip is this. BQ25A. 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 Let's wait. Yeah. BQ25A. BQ25A data sheet. Charging controller. I'm trying to look for the data sheet. Let's wait. Yeah, the internet speed is very crazy, very slow. Desktop download. Let's go on desktop. Desktop, the BQ. Yeah, that's the data sheet for the BQ25A. Pin number 20, that's the VCC pin. Pin number 20 and the pin number AC detect pin number 6. Okay. So probably this capacitor which is shorted is on the V in. So I will replace this chip quickly, and after that we'll see. I'll replace this PQ chip. That should be fine. I can't see my thermal page. Let me check if all the pins are okay. Let me check. So let's see now. Yeah, the input circuit, nothing is working here. We replaced the MOSFETs. Still, the first MOSFET is not driving because the BQ chip, the BQ chip is shorted. So let's check on that capacitor. Same way we checked. This is ground, and there's no more short again. So clearly the BQ chip was shorted. Do we now? The question is our first MOSFET now open? Let's see. And we have the charging you have the charging light, you see. So our first MOSFET is now passing 19 volts from drain to source. You know, you have to put the right diagnosis on the output. Okay, I'm on diode mode, volts 19, on the current sensor 19. Let's check on these power supplies. On ceramic capacitors 19.6. Okay. On this power supply 19. What is the second step? Is to check for 3.3. On the ENE chip, we have some capacitors around the ENE chip. 3.3, you can see on the screen 3.3, and here 3.3. That means on the power button, power connector here, that the connector for the which is going to the power on button, we must have 3.3, 3.3, 3.28, 3.27, 0. So probably this is ground. So our board is ready to be powered on. We don't have the switch, so I'll try to short pins to ground. So how am I going to see if this board is on? Any sign of light here? But we'll see. Let's check some voltages. That's the only way we can see if this board is now on. 3.3, 5 volts. When the CPU is getting warm. What about on this power supply? 1 volt. 1 volt. This one for charging. Okay. RAM voltage 1.35. So yeah, the board is now on. How we can test this? Let's see how we can test this. So what I did, I connected the HDMI. This is, we have the light. Yeah, this is my cable. I just see we don't have a switch. So in order, when I'm shorting pins, I just improvise this cable which is going to the USB, and we have the light here. And let me adjust my webcam. Let me adjust. It's working. It seems as if we have done our part. I'm trying to adjust the webcam. You see, You see no boot device not found. Please install an operating system. So it's fixed. So I'll stop this video now, and I'm very happy. You know, jobs from other cities, the person has put all the trust on you, and you have to be professional. We started when you see the blown up area. The first MOSFET was blown up, the second MOSFET was blown up. I changed all the MOSFETs. I changed those black inductors, whatever you call it, before the MOSFETs, just soon after the charging port. I changed all those blown up things. The first MOSFET was not driving the power from drain to source, and like always, sometimes we are shorting the MOSFET, which is something dodgy and shortcut, but you have to understand why the MOSFET is not driving the 19 volts. We checked around the BQ chip, there was no V in voltage, because the BQ chip, the way how it is working, the pin number 1 is the input pin. We must have 19 volts, and the pin number 6, that the AC detect pin is detecting if the charging current for the power pack is okay. If it's not the right current, it will communicate with the EC chip to shut down the input MOSFETs. That's how things are working. So I'm happy, because even the BQ chip, you see this, the BQ chip, maybe you can see here, was gone. So I'll stop this video. Like, subscribe, see you on the next one. Don't forget to share our videos to beloved friends and relatives. Bye.